Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 10 video on the chapter of area of trapezium and polygon, where I will solve the problems of test paper 18, which has problems based on the entire concept of area of polygons as well as quadrilaterals, trapeziums and triangles. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the problems of test paper 18 on the chapter of area of quadrilaterals, trapezium, triangles and polygons. Okay, so I have the test paper on the top part of the screen. This is test paper 8. There are in total all the questions are divided into section A, B and C, and there are total of 14 questions. So okay, I hope the fonts are big enough so that you can also read the problems properly. Since I have placed the problems above the canvas where I will write, I have now a little less space in the canvas to solve the problems, so I have to manage space. Okay, so let's get started in solving the problems. Question number, so this is section A, question number 1. It says the base of a triangular field is 3 times its height and its area is 1350 meter square. Find the base and height of the field. So we know that the area of a triangle is half into base into the height. It is saying that the base of a triangular field is 3 times its height. So let base be x meter, since the unit of area is given in meter square. So let base be x meter. So this will imply height will be equal to, it is given the base of a triangular field is 3 times the height. Okay, so it's better we consider the height. So let height of the triangular field be x. So this will imply the base will be equal to 3x meter. So this implies the area A will be equal to half into base, that is 3x, multiplied by height, that is x, this much meter square, which is equal to 3x square by 2 meter square. So the area is given to be 1350 meter square. So we must have 3x square by 2 is equal to 1350. So we are having an equation in x square, no problem. So x square will be equal to 2 by 3 multiplied by 1350. So let's simplify the right hand side and we get 450, this is 900, so which is a perfect square. So x will be equal to square root of 900 meter, which is equal to 30 meter. So x is 30 meter. So it is asking to find the base and height. So this will imply that base was we assumed height to be x meter. So base will be 3x meter, that is base is 330 into 3 meter, which is 90 meter, and height we assume to be x, which is 30 meter. Half. Let me quickly check if the calculation is correct or not, or it's better. I am prone to make calculation mistake. Let me quickly check the answer. Base is 90 meter and height is 30 meter. Okay. So this was pretty straightforward question. Okay. Question number 2. Find the area of an equilateral triangle whose side is 6 centimeter. Equilateral triangle whose size is 6 centimeter. There is a formula for the area of an equilateral triangle based on the side of, based on the length, each of its side length. But let's try to find that formula or derive that formula. So we have, so let's say I'm approximately, all my figures will be approximate, it will not be accurate, so please keep this in mind. Let's say this be an equilateral triangle. So obviously let's say each of the sides are of length a. Now if I drop, so the altitude, considering BC as the base, the altitude will be the perpendicular from the vertex A on BC. So this is, now can we find the length of, let's say this is AO. So AO is perpendicular to BC and AO is equal to height of triangle ABC with base PC. Now can we find the height H, the height of the, that is, can we find the length of the segment, line segment AO. Now please note that the altitude AO, altitude will, since this is an equilateral triangle, in fact if ABC is an isosceles triangle where angle B is equal to angle C, and if you drop a perpendicular from vertex A on BC, then the foot of the perpendicular, the perpendicular will bisect the base BC. So so we will have AO will bisect BC. This implies that BO is equal to OC is equal to BC by 2, which is A by 2. So now in triangle, in the right angle triangle, let's say AOB, in the right angle triangle AOB, from Pythagoras theorem we will have AB square is equal to OB square plus AO square. This implies AB square is A square and OB square is A by 2 whole square plus AO square. This will imply that AO square will be equal to A square minus A square by 4, which is 3A square by 4. So this implies AO will be square root of 3 divided by 2A. So the altitude of an equilateral triangle where each side length is A is root over 3 by 2A. So now we can say this implies area of triangle ABC will be equal to half base, which is BC, height, which is AO, will be equal to, BC is A by 2 multiplied by AO, the height, altitude, is root over 3 by 2A. This is root 3 by 4A square. So this is the formula of the area of an equilateral triangle having side length of A. So now if we in this problem, if we apply this formula, the area will be root over 3 by 4 multiplied by the side length is 6 square. This will be centimeter square. This is equal to 9 multiplied by root 3 centimeters square. So let me check the answer. It is 9 root 3 centimeter square. So this is an important formula. You must remember that for an equilateral triangle, if the length of each side is A, then the height altitude is root over 3 by 2A and the area becomes root over 3 by 4 A square. A square. Okay. Let's see the problem number for problem number 3. We are still in section A. Problem number 3. The perimeter of a rhombus is 180 centimeter and one of its diagonals is 72 centimeter. So we are dealing with a rhombus. Let's quickly draw approximately a rhombus. Let's say this is a rhombus. We know in a rhombus all the sides are equal. Rhombus is a parallelogram where all the sides are equal, and of course the diagonals bisect at right angles. The diagonals bisect at right angles. Let's say ABCD with the rhombus where the diagonals are intersecting at the point O, rather bisecting at the point O at right angles. Okay, the perimeter of a rhombus is 180 centimeter and one of its diagonals is 72 centimeter. Find the length of the other diagonal and the area of the rhombus. Now we know, okay, let's solve it step by step. So the perimeter, let's say each side of the rhombus be A. So we have the perimeter of the rhombus, perimeter P, perimeter is equal to the units are given in centimeter. So let's say perimeter is 4A centimeter, where length of each side as per our assumption is A centimeter. So this will imply 4A is equal to 180. This implies A is equal to 180 by 4, which is 45 centimeter. So each side of the rhombus is 45 centimeter. Okay. Now one of its diagonal is 72 centimeter. So let's say let AC be equal to 72 centimeter. AC is 72 centimeter. Now since the diagonals are bisecting each other, we will have AO will be equal to AC by 2, which is 72 by 2, which is 36 centimeter. So AO is 36 centimeter. Okay. Now how do we find the other diagonal BD? BD will be twice of OB. Now in right angled, we know that in the rhombus ABCD, since the diagonals are intersecting at right angles, triangle AOB will be a right angle. So in right angle triangle AOB, using Pythagoras theorem, we will have AB square is equal to AO square plus OB square. We need to find OB. If we find OB, we will get BD, which is the other diagonal. This implies what is AB? AB is one side of the diagonal, which is 45, So 45 square is equal to AO square. What is AO? AO is 36 square plus OB square. Now to solve this kind of equation, where you see in a Pythagoras theorem especially, if you need to find OB square, please do not find the value of 45 square and 36 square. Rather, you see OB square will be equal to 45 square minus 36 square. I will use the formula algebraic identity A square. There is an algebraic identity you have already learned in the chapter of algebraic identities and expressions, that A square minus B square, that is x square minus y square, is x minus y multiplied by x plus y. So this will be 45 plus 36 multiplied by 45 minus 36. This is equal to 81 multiplied by 9. So now you can see this is 81 is 9 square and 9 is 3 square. So this becomes 27 square. So it's easy if you apply the formula A square minus B square. So this will imply OB is equal to 27. OB is 27. So this will imply the other diagonal BD will be equal to twice of OB, which is equal to 2 multiplied by 27 centimeter, which is equal to 54 centimeter. So the question has asked to find the length of the other diagonal, which is 54 centimeter, and the area of the rhombus. Now what will be the area of a rhombus? Note that each diagonal in a rhombus divides the entire rhombus into two congruent triangles, and definitely the area of two congruent triangles are equal. So if I consider the diagonal AC, the diagonal AC is dividing the entire rhombus into two congruent triangles, ACB and ADC. So what is the area of let me quickly copy this figure so that it will be easy to refer. Okay, now I have to find the area of the triangle of the rhombus. Okay, now we can see that the area of the rhombus ABCD, in short I am writing AR for area, will be equal to area of triangle ACB plus area of triangle ADC. This is equal to twice of area of triangle ACB. Why? Because triangle ACB is congruent to triangle ACD. These two triangles are congruent and hence their area will be equal. Now what is the area of triangle ACB? So we have 2 into the area of triangle ACB is half. Let's consider AC as the base, AC multiplied by, if AC is the base, the altitude will be OB. Okay, so half and 2 gets cancels out. We have AC into OB, AC into OB. Half AC into OB. Okay. Okay. So what is AC? AC we have found earlier to be, AC is given to be, AC what was AC? AC we have assumed to be 72 centimeter. Okay. So AC is 72, and what was OB? OB is half of OB is half of BD, which is 36. So in a rhombus, you see the area of a rhombus is half multiplied by the product of the diagonals. So this much centimeter square. Now what is 72 multiplied by 36? I think I have done some mistake. What is OB? OB is half of BD. OB is 27. Okay, so OB is 27. Now what is 72 multiplied by 27? 14. Uh, 4491. So this is 1944 centimeter square. So the area of the rhombus is 1944 centimeter square, and the length of the other diagonal is 54 centimeter. It is correct. So one formula you might already be knowing from your previous class, that the area of a rhombus is half into product of the length of the diagonals. Okay, let's do problem number. This was problem number 3. Let's do problem number 4. The area of a trapezium is 216 meter square and its height is 12 meter. If one of the parallel sides is 14 meter less than the other, find the length of each of the parallel sides. Okay. So as per our assumption, I always assume the length of the parallel sides to be x and y, where x is the length of shorter parallel side and y is the length of larger parallel side. So let parallel sides be of length. It is given that one of the parallel side is 14 meter less. So if the shorter, if x is the length of x meter is the length of the shorter parallel side, then the length of the longer parallel side will be x plus 14. So x meter and x plus 14 meter are the length of the parallel sides. Okay, so this implies area is equal to area of the trapezium we know is half multiplied by the sum of the parallel sides. In this case, it will be x plus 14. And multiplied by height. Height is given to be 12. This implies this is equal to 2 cancels 12 with 6, and inside we have x plus 14, which is 2x plus 14. From the expression 2x plus 14, we can take out 2 as common, and we will have 12 multiplied by x plus 7. Now the area of the trapezium is given to be 216 meter square. So we have 216 is equal to 12 multiplied by x plus 7. So this is the linear equation in x. We can easily solve for x. Will 12 divide 216? Yes. So dividing, so we will have 216 divided by 12. If you divide both LHS and RHS of this equation with 12, we get 216 divided by 12 is equal to x plus 7. This implies the left hand side 216 divided by 12 is 118. So 18 is equal to x plus 7. This will imply x is equal to 18 minus 7, which is 11. So x is 11, that is the shorter length of the shorter parallel side is 11 meter. So this will imply length of parallel sides are x, which is 11 meter, and 11 meter plus 14 or 25 meter. So 11 meter and 25 meter are the length of the parallel sides. Let me quickly check if the answer is correct or not. It is correct. Okay, let's do the problem number 5. Find the area of a quadrilateral, one of whose diagonals is 40 centimeter and the lengths of the perpendiculars drawn from the opposite vertices on the diagonal are 16 centimeter and 12 centimeter. So this is a straightforward question. We know that whenever we are having given in a quadrilateral, say ABCD is a quadrilateral, and we are given one diagonal, let's say AB, and we are given the length of the perpendiculars drawn on this diagonal BD from the opposite vertices, which are A and C. So these two, length of these two perpendiculars are given. Let's say these two perpendiculars are the length of these two, let's say the perpendiculars are AE and CF. So the area formula we have already studied, that area of the quadrilateral ABCD will be equal to half multiplied by the diagonal BD on which the perpendiculars are drawn, multiplied by the sum of the perpendiculars drawn on the diagonal BD, that is AE plus CF. AE plus CF. So this is the formula for finding the area of a quadrilateral. So in this problem, applying this formula directly, we get the area of the quadrilateral will be half multiplied by the length of the given diagonal, which is 40, and the lengths of the perpendiculars, two perpendiculars, are 16 and 12. So this much centimeter square. So this is equal to 20. 40 divides 2 divides 40 by 20. 20 multiplied by 16 plus 12 is 28. 28, this much centimeter square. This is equal to 560 centimeter square. So the area of the quadrilateral is 560 centimeter square. Okay, let's do problem number 6. A field is in the form of a right-angled triangle with hypotenuse 50 meter and one side 30 meter. So the field is like a right-angled triangle. Let's say ABC be the field with the right-angled at B. So AC is the hypotenuse. It is given as 50 meter and one side is 30 meter. Let's say this is 30 meter. This is 30 meter. Find the area of the field. Now it will not matter if you consider BC as the 30 meter. It will not matter. The answer will come the same. The answer will be same. So the idea is, you are given the hypotenuse on one side. Using Pythagoras theorem, you have to find the length of the other side. And now you can easily see that the base and height will be the two arms of the triangle, right angle triangle ABC. So first let's find what is BC. So we have from Pythagoras theorem, AC square is equal to AB square plus BC square. This implies 50 square is equal to AB is 30 and we have BC square. So this implies BC square will be equal to 50 square minus 30 square. this is equal to, applying the formula a square minus b square is equal to a minus b into a plus b. This is equal to 50 plus 30 multiplied by 50 minus 20. Sorry, 50 minus 30. So this is 80 multiplied by 20. And this is 1600. So this will imply BC is equal to square root of 1600, which is 40. So BC is 40 meter. So now what will be the area of the field? Area of triangle ABC, that is the field, is equal to half into AB into BC, which is equal to half into AB is 30 multiplied by BC is 40. This much meter square, which after simplification will be 20. So 600 meter square. So 600 meter square is the area of the triangular right angle, the field which is in the shape of the right angled triangle. Test paper 18, problem number 6 is 600 meter square. Okay. So this was the end of section A. Now let's start section B. Section B are all multiple choice questions where only one choice will be correct. Section B, question number 7. The base of a triangle is 14 centimeter and its height is 8 centimeter. The area of the triangle is, it's pretty straightforward. Area is equal to half into base into height, which is equal to half. Base is given as 14 and height is given as 8, this much centimeter square, and this will be 456 centimeter square. So the correct choice will be B. Even though this is a very straightforward simple question, still I am checking the answer. 9, this is 7B. Question number 8. The base of a triangle is 4 times its height and its area is 50 meter square. The length of its base is, okay. So let base be, since the unit is given in meter square, meter, so let base be x meter. The base of a triangle is 4 times its height. Okay, it's better we consider height as, let height be x meter. This implies base will be equal to 4x meter. This will imply area is equal to half multiplied by base, which is 4x, multiplied by height, which is x. This is 2x square. So this implies the area of the triangle is given to be 50 meter square. So we have 2x square is equal to 50. This implies x square is equal to 25. This implies x is equal to square root of 25, which is equal to 5. So the height is the length of its base. The question has asked what is the base. So this implies base is equal to 4 into x, which is 5, this much meter. This is equal to 20 meter. So the answer is the correct choice is C. Question number 8, the correct choice is C. Okay. Let's do question number 9. The diagonal of a quadrilateral is 20 centimeter in length and the lengths of the perpendiculars on it from the opposite vertices are 8.5 centimeter and 11.5 centimeter. The area of the quadrilateral is. So we know that if we have a quadrilateral like this and let's say ABCD, let's say BD be the diagonal on which the perpendiculars are drawn, let's say these two are the perpendiculars, let's say AE and CF. So area, we know that area of the quadrilateral ABCD will be equal to half multiplied by the diagonal, the length of the diagonal, which is BD, multiplied by the sum of the perpendiculars, that is AE plus AF. Now if we put the values from the given problem, the length of the diagonal is given as 20 centimeter, multiplied by the sum of the length of the perpendiculars will be 8.5 plus 11.5. So this much centimeter square will be the area. So this is equal to 10 multiplied by 8.5 plus 11.5 is 20. So the area is 200 centimeter square. So the correct choice is B. B is the correct choice. Okay. Let's do question number 10. Each side of a rhombus is 15 centimeter and the length of one of its diagonals is 24 centimeter. The area of the rhombus is, each side of a rhombus is 15 centimeter. So we know that, let's say this be the rhombus, and we have the diagonals will bisect each other at right angles. So we have each side of the rhombus is 15 centimeter and the length of one of its diagonals is 24 centimeter. Okay. Let's say the rhombus is ABCD. Let's say let AC, let the diagonals be intersecting at the point O. So let AC be the length of AC be 24 centimeter, and we have AB is equal to the each side of the rhombus, which is 15 centimeter. Now we will know so the area of the rhombus is, now the area of a rhombus is half into half and half multiplied by the product of the diagonals. So the area of the triangle, area of the rhombus ABCD of a rhombus is half multiplied by the product of the diagonals, that is AC multiplied by BD. We already know the length of the one diagonal AC, that is length of one diagonal is given 24 centimeter. If we can somehow find the length of the other diagonal, we can find the area. So we need to find BD. Now BD will be twice of OD, because the diagonal BD, both the diagonals are being bisected at the point O. Using Pythagoras theorem, we have to find OB first from triangle AOB. So OB square, I am directly applying the formula Pythagoras theorem. OB square will be equal to AB square minus AO square. This is equal to AB square is 15 square minus what is AO? AO is half of AC, and AC is 24 centimeter. So 24 centimeter. So AO is AC by 2, which is 12 centimeter. So we have 12 square. So this is equal to 15 minus 12 multiplied by 15 plus 12, and this is equal to 3 multiplied by 27, and this is equal to 81. This is equal to 9 square. So this will imply OB is equal to 9 centimeter. If OB is 9 centimeter, this will imply BD will be twice of OB. This is 18 centimeter. So the length of the other diagonal is 18 centimeter. So now the area will be half multiplied by the product of the diagonals. ACE was given as 24 and BD we have found to be 18 centimeter square. So this is equal to 144 centimeter square. I hope no. I think I'm wrong. What is 18 multiplied by 12? 36 and 18, 612. So this will be 216 centimeter square is the area of the rhombus. So the correct choice should be B. Question number 10, the correct choice is B. Okay. Let's do question number 11. The area of a rhombus is 120 centimeter square and one of its diagonal is 24 centimeter. Each side of the rhombus is. The area of a rhombus is, so the area is given and one of its diagonals is given. Each side of the rhombus is. Okay. Now we know that. So if this is the rhombus, we know that one of its diagonals is 24 centimeter. So let's say this is the rhombus ABCD. Let's say AC is given to be 24. The diagonals will intersect, bisect each other at right angles. Let's say they bisect each other at the point O. AB each side, we have to find each side. Let's say each side be A. Centimeter. So we have AC is 24 centimeter and and AB we have considered the length of each side as A centimeter. Okay, now first of all we are given the area of the rhombus and the length of one diagonal is given. So definitely we can find the length of the other diagonal. So we know that area of rhombus ABCD is equal to half multiplied by product of the diagonals, length of the diagonals, which is AC multiplied by BD. So this implies the area is given to be 120. 120 is equal to half multiplied by AC is 24 multiplied by BD. This is equal to 12 BD. So this will imply BD is equal to 120 by 12, which is 10. So BD is 10 centimeter. So if BD is 10 centimeter, this will imply OB will be equal to half of BD, which is equal to 10 by 2 centimeter, which is equal to 5 centimeter. So in the right angle triangle AOB, we know what is AO. AO will be half of AC, which is 12 centimeter. And we also know OB is 5 centimeter. So we can easily, using Pythagoras theorem, we can easily find AB. So in triangle AOB, AB square is equal to AO square plus OB square, which is equal to AO is 12 centimeter. So 12 square plus OB is 5. So we have 144 plus 25, which is 169. So this implies AB is equal to square root of 169, which is 13. So the length of each side of the rhombus is 13 centimeter, and hence the correct choice is B. B is the correct choice. Question number 11, B is the correct choice. Okay. Let's do question number 12. The parallel sides of a trapezium are 54 centimeter and 26 centimeter, and the distance between them is 15 centimeter. Find the area. This is a very straightforward question. Area of trapezium is equal to half multiplied by the sum of the parallel sides, where x and y are the length of the parallel sides, multiplied by the altitude of the trapezium, which is the perpendicular distance between the parallel sides. So the parallel sides, length of the parallel sides are given as 26 and 54, and the height is given as 15. So the area will be this much centimeter square. So this is 15 by 2 multiplied by 26 plus 54 is 80. 2 cancels 80 with 40. So this is equal to 600 centimeter square, and hence the correct choice will be D. Question number 12, D should be the correct choice. Okay. Question number 13. The area of a trapezium is 384 centimeter square. Its parallel sides are in the ratio 5:3, and the distance between them is 12 centimeter. The longer of the parallel side is. Based on the ratio, let the parallel sides are of length 5x and 3x centimeter. Okay. This will imply the area of the trapezium. The area of trapezium will be equal to half multiplied by the sum of the parallel sides, which is 5x plus 3x, multiplied by the height, which is given as 12 centimeter. The distance between the parallel sides in a trapezium is the height of the trapezium, 12. This is equal to 6 multiplied by 8x, which is 48x. This implies the area of the trapezium is given to be 384 centimeter square. So we must have 384 is equal to 48x. So this implies x is equal to 384 divided by 48, which is equal to 8. So x is not centimeter, but x is 8. X is 8. So this will imply it is asking the longer side. So length of longer parallel side will be equal to 5 multiplied by x centimeter, which is equal to 40 centimeter, and hence the correct choice will be B. B is the correct choice. Question number 13, B is the correct choice. Okay, let's do question number. So this brings to an end of section B, that is multiple choice question. Now let's do section C. These are all fill in the blanks question. Question number 14, part 1. Area of a triangle. So area of triangle we know is equal to half multiplied by base. These are just to revise your very basic fundamental concepts and formulas. Half into base into height. Part 2, area of parallelogram. Area of, this is a short notation for parallelogram. Okay, so area of a parallelogram I think is half into also base into height. Area of a parallelogram, half into base into height. where if I remember correctly, if this is a parallelogram, then this can be a base. You can consider, if you consider, so we have, let's say AB CD is the parallelogram. Let's say this side is X, so this will be also X, and let's say this side be Y. Y means the length of these sides be Y. So the area of ABCD, that is a parallelogram ABCD, will be half multiplied by X multiplied by H, where what is H? H is the distance between the parallel sides AB and DC. If you consider AB or DC as the base, then the height will be the distance, perpendicular distance between them. So if I draw a perpendicular from C to AB, if this is H, if CE is H, then CE will be the height of the parallelogram considering the base as DC or AB. It could be other way around. If you consider the base as Y, then you have to consider the height between that is the perpendicular distance between the parallel sides AD and DC. So in any way, in either way, the formula is half into base into height, where height is the distance between the parallel sides, which is considered as the base. I will do all the fill in the blanks and then I will check the answer. Area of a trapezium, area of a trapezium is half multiplied by sum of parallel sides, multiplied by height, where height is the distance between the parallel sides. Part 4 is the parallel sides of a trapezium are 14 centimeter and 18 centimeter, and the distance between them is 8 centimeter. The area of the trapezium is. So it's a straightforward question. Area of trapezium will be half into sum of the parallel side, which is 14 plus 18 multiplied by the height, that is the perpendicular distance between the parallel side, which is 8, this much centimeter square. So this will be 4 multiplied by 32 centimeter square, which is equal to 128 centimeter square. So let me quickly check. I hope there are no more questions. Okay. Let me quickly check the answer of the question number 14. Fill in the blanks. One is base and height, that is fine. Second one is also base and height, that is fine. Area of trapezium is sum of parallel sides and distance between them, that is fine. And 4 is 128. So in the fill in the blanks, the answer will be 128, since centimeter square is already given. So this brings to an end in solving the test paper 18 based on the concepts of area of triangles and quadrilaterals and parallelograms, trapeziums and polygons, even though there and polygons. Ideally, you should be able to solve these 14 questions in 45 minutes, or at max 1 hour. So in solving these problems, I hope this video will be beneficial to you in understanding how we are applying the fundamental concepts and formulas of area to solve the problems. So if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So this brings to an end in completing the entire chapter of area of trapezium and polygons and solving all the problems of exercise, and finally the test paper 18. Now I will parallelly start solving 5 good problems which will be relatively harder in the other playlist, that is Maths 8 Hot, on this chapter of area of quadrilaterals, trapeziums, triangles and polygons. So please keep an eye of the upcoming video 5 good problems in the other playlist, that is Maths 8 Hot. I will end the video here. Thanks for watching, and until the next video, take care and bye.